Good afternoon, Year 10 Computer Science students. So in this lesson, we're looking at trace tables. Trace tables is a way that allows us to check whether a flowchart performs the way it should perform. Are the variables within the trace table doing what we think they should be doing, or are they behaving in a different way? So it's a mechanism that allows us to test and check what's happening within a flowchart. So first thing is, up until now, you've been doing a fair bit of work on flowcharts, flowchart symbols. You've done some work in Flowall and you've done some programming. So we're looking at testing the flowchart itself. So one of the beauties about a trace table is you can look at things at a step-by-step level. So what's happening at each level of, or each symbol of the flowchart, is it behaving in the way it should? And we record that in a table, and then we can look at the table and make a determination as to whether it's doing what it is that we wanted it to do or not. So the example over here on the left-hand side, I've got a little program. I haven't put it in a flowchart, but just look at the 7 instructions. I input N1. N1 is 5. We can see that on the right-hand side of the screen. Then max equals N1. So max is going to equal whatever N1 is. N1 was 5, so max equals 5. Then we input N2. N2 is 7. Is N2 bigger than max? And if it is, then max becomes N2. So basically what's happening over there is either N1 is going to stay as max, or N2 is going to be overwritten into max, because N2 looks like it's the bigger number. In this instance, 7 is bigger than 5, so 7 should become max. Then line number 5, input N3. N3 is 4. Is N3 bigger than max? Max is 7. N3 is 4. It's not, so it should ignore moving N3 into max, and then output max, and the max would be N2, which would be 7. So let's go line by line. What happens? Input N1, so N1 becomes 5. Okay, next line, max becomes N1, so we just put 5 in the max box. Then we input N2, and you can see I've done this on the second line because 7 was inputted after the max of 5. So therefore, we want it to follow in chronological order. Is N2 bigger than max? If it is, then max becomes N2. So it is true, so max becomes 7. Then we input N3. So next line, we input 4. Line number 6, it doesn't happen. Max stays as 7. And so we output 7. And there we are, we've got a trace table that works. If somewhere along that journey, for example, output happened to be number 4, we know that doesn't work, and it's wrong. So we need to figure out where it went wrong, and then we would work along that. A brief note here: when we're writing this table, one of the mistakes that students make is just the fact that they don't consider the order. So in this example algorithm, we've got 0, 0, 1, and then 50. So we want to consider at what point did things happen. And if we look at the table on the right, it says A happened, then which was 0, B happened, which was 0, and then X happened, which was 50. That's not what happened. 1 happens before 50. And so this is wrong. It's the 50. It looks as if you're running through the table, 50 happened before 1, and that wasn't the case. What we really want to do is make sure that 50 comes after the A becomes 1. So then again, if we look on the left-hand side at the algorithm, 0, 0, 1, 50, and if we follow the table from left to right, 0, 0, then move to the next line, 1, and then 50 comes after the 1. So you can see that working there quite nicely. Very, very important that you're aware of the symbols, the more than, the less than, the not equal to. Usually the mistakes come about when students are not being careful with the symbols, the relational operators, the arithmetic operators, all of those, just being very careful on those. So your task this lesson is just to make sure that you can do 3 sets of trace tables. I've attached a worksheet for yourself to work through, and then the mark scheme is at the end of this PowerPoint, so I'm not going to whiz through that. You can go and have a look at the answers once you've had a go at the questions.